All right, in this problem, we are being asked to tell whether the volume of the prism is a linear or a nonlinear function of the missing dimension. So what type of a prism are we dealing with? This is a triangular prism. Let's write out our formula for volume. Volume is going to be equal to 1/2 base times height times length. Okay, we got our base, our height, and our length right here. So we would just be plugging those numbers in for these variables. But the question is being asked, is it linear or is it nonlinear, right? Okay, well, what do we know about linear versus nonlinear equations? Here's how we can write a linear equation out. It has to have a constant rate of change. So right here we have our constant rate of change, mx, and then we have a starting value or an initial value. We call that the y-intercept. But this means we have a slope, a constant rate of change. It can be written in slope-intercept form. Sometimes we write them out in standard form, okay? Ax plus by equals c. Those are what linear equations look like. Nonlinear equations, nonlinear functions, they're going to have different parts to the function. For example, it could be a quadratic. Quadratics have x squared in there. We could have an absolute value function. That means we're going to have absolute value bars around the x, which means we're going to have that V shape when we graph it. We can have cubics, right? Y equals x cubed. Nonlinear, nonlinear, nonlinear. We could have square roots, which would make nonlinear functions. We can have exponential functions, but one big takeaway from all of these is most of them have an exponent, okay, other than 1. Constant rate of change would have an exponent of 1, we just don't show it. Or they have some other symbol, mathematical symbol, whether it's a radical, square root, or absolute value bars. So what we got to do is we got to plug this in, plug our information in, and let's find out what type of a function we get when we're done with this. So volume is going to be equal to 1/2 times our base. Our base in this case is b, times h, which is 3. Whoops. Times our length, which in this case is 4. 3 times 4 is going to give me 12. So now I've got 12b inside the parentheses here. We're going to multiply that by 1/2. Half of 12 is 6. So v is equal to 6b. This is no different than writing out the equation of y equals 6x. Y equals 6x. Y equals 6x with a starting point of 0. Output of y, input of x. No matter what we plug in, we're always going to be increasing by 6 every time x increases by 1. So because of that, this has a constant rate of change, meaning if we were to graph it based off of volume and the missing value here, we would deal with a linear function, a line. Hopefully this makes sense. Study hard and good luck on your upcoming test.